Welcome back, folks. I'm just going to do a quick little video for today, and what I'm going to do it on is the frequency response of our little one transistor Class A amplifiers here. So I've got a single stage set up here now, and I've got it in swamped emitter mode. As far as I'm concerned, that's the preferred setup. It's a nice balance between gain and distortion, and we saw that in the last video. We've got a gain of 18, so I've set up the scope here. If you look up there, you'll see that I'm going to sweep from 10 hertz all the way out to 2 megahertz. And in my experience, that should be appropriate for this kind of setup. And I'm going to, because we have a gain of 18, that's in decibels, that's about 25, thereabouts. So I've got a vertical scale and kind of match that. And I'm doing about 30 samples per decade here. So it should produce a fairly nice little graph. So let's go ahead and do that. Let's start this thing running, and we'll come back, and I might adjust the scales here for viewing at the end, and we'll have a look at what the frequency response is like. Okay, so there we are. So it looks like we reach a maximum of about 25.5 dB up here at about 150 kilohertz. And we're down a couple of dB by the time we get to 2 megahertz. So I imagine it would run out to probably 2.5 megahertz. We started off down about 3 dB at 10 hertz. So it's basically flat from 10 hertz out to 2.5 megahertz. That's a pretty useful little amplifier. And if you were to take a little bit more care in the design and specification of the components, you could probably run something like this out much further. The transistor itself is rated for unity gain out to 300 megahertz. So if you wanted a gain of 10, you could probably easily get out to in the 20 to 30 megahertz range. I'm going to set up here for the dual stage amplifier, and we'll run the boat plot on that and see what that looks like. Okay, I've got it all set up here in a dual stage amplifier, and as we saw in the last video, I mean, that's going to add about a gain of about 6 over the single stage for a total of over 100 between the two of them. That would amount to about another 15.5 dB. So with this one coming out to 25.5 dB, it should be combined, it should be around about 41 dB total gain. But let's see what the effect is of having two stages is on the bandwidth. So let's get that started, and we'll come back when it's finished. Okay, so this actually looking like it's a little bit flatter overall, not much. Didn't quite make it to 41 dB, but it looks like it peaked at again around about 150 kilohertz, and around about 40.5 dB. And it looks like we're down 3 dB at about 15 hertz in this case, rather than at 10. So we lost a little bit of frequency response on the low end and a little bit at the high end. We're down again at minus 3 dB at 1.5 megahertz, thereabouts. If you notice there, the dark blue line, that's the phase. You have a phase angle of about 70 degrees, but by the time you get up around 100 hertz or so, you're pretty close to zero. And then that remains that way until you get up to a couple hundred kilohertz, and then it starts to drift off due to inductances. So that's very interesting. So a very handy little amplifier, the kind of broadband if you're thinking in terms of lower frequencies. So all the way from 10 hertz up to 2 megahertz, you've got amplification here. All right, thanks guys for joining me. Really appreciate it. Give me a like, subscribe if you haven't yet, and you can always help out the channel by clicking on the link in the description. Go over to PayPal and buy me a coffee. All right, see you in the next one. Bye bye.